Thanks everyone for coming back. I guess we should get started now. We've got two talks. We'll take a 15-minute break between them, same as this morning. There's some snacks in the back and coffee and everything if you didn't see. Hopefully everyone who has a laptop was able to download the SPSS program, the trial version, and receive the files from Josh that I sent. If you didn't, let me know and I'll re-email them. And other than that, I just want to welcome Josh Knobe, who's professor of cognitive science and philosophy at Yale University. Thanks, Josh.
In this moment, in this talk, we're going to be transitioning from this more kind of theoretical questions about how to understand what statistical analyses really are, how to think of organizational experimental design, and so forth, to these really practical questions. Say you just have some data on your internet. What do you actually do when you're trying to analyze it? So on a really practical level, how do you go about actually analyzing the data? And as we'll see, a lot of what we're doing in this next hour and 15 minutes just involves kind of applying the key concepts and ideas that you saw already from Simon's talk and from Virginia's talk. So you had a real grasp of what those people were up to, what they were trying to communicate to you. Now we get to sort of apply that, and hopefully you'll emerge with a sort of deeper understanding of the kind of things that they were after, because you'll be getting a chance to actually use those things in understanding some particular data sets. So the basic way we're going to proceed is this, that I'm first going to sort of go through a demonstration of how you would analyze a particular data set. It's kind of just like an imaginary data set. It'll give you a sense of how to do these kinds of things. And maybe just by watching it, you can get to some degree an understanding of what's going on. But I think the real way that you'll actually learn these things is by doing it yourself. So we have another imaginary data set, which Michael sent out to all of you. And I'm going to give you some questions that you're going to try to answer by looking at the data in that data set. Then, as you start working through these questions and trying to actually apply the knowledge that you've got, hopefully you'll emerge with a really good understanding of how this stuff works. So I'm going to demonstrate this stuff now. You can sort of watch how it goes, try to sort of remember how it works. Then you're going to get a chance to apply it for yourself. And if you have any questions, we can sort of help you out with it. But I think by the time you end up really applying it for yourself, you'll end up with a much better understanding of how these kinds of things actually work. So before I begin doing this, just two quick notes. The first note is that what I'm going to be trying to do now is to explain just certain relatively basic things. So we're not going to be talking in really a serious mathematical or theoretical detail about how this stuff works. We're just going to be trying to understand on a basic level how to do this. And my aim is not to be really ambitious and try to get you to understand a lot of stuff, but rather to make sure you really understand the very basic stuff that we're going to be trying to communicate. So the goal is to cover very few things, but to make sure that by the end of the hour and 15 minutes, you really understand those things. Second thing I want to communicate is that what we're going to be trying to do now is to understand the super kind of orthodox way of doing statistics. So just the very standard way of doing statistics. In Simon's talk, she provided some really good sort of objections to this very orthodox way of doing things. So there are people who think that this orthodox way of doing things is really mistaken in important ways. I think there's really a lot to that. But it's very important, I think, for you guys to understand how to do the orthodox thing. Even if you think the orthodox thing is wrong, maybe you think you shouldn't be doing these kinds of things that I'm talking about here, you should at least understand what it is, how to do it. So maybe if you end up being statistical rebels and you end up thinking there's a mistake in this kind of very orthodox way of doing things, you'll emerge, at least at the end of the hour and 15 minutes, with a sense of what it is that you're rebelling against. So in sort of presenting these basic techniques, we need an example. And the example we're going to be using is a study that was actually conducted by Fiery Cushman and colleagues, and it was published in the journal Cognition. But even though this is a real study, the data set that I'm creating is just an imaginary data set, so it's like fake data from a real study. So this is an actual study that was really conducted, but I'm going to be illustrating the kind of analysis on this study by just using some sort of made-up data that can help. So we're going to be going through I'm going to first explain sort of how the study worked, but of course, you don't really have to remember anything about this. It's not really important to know what was actually going on in this study. We're just using this as an example so that you can get a sense for the use of certain kind of statistical techniques. So with that, let's just begin with basically what this particular study was. So the basic idea in this study was that participants were randomly assigned to one of two conditions. participants in one condition will receive what was called the morally ambiguous condition. So participants in this condition were told about a doctor who performs an action that's morally ambiguous in the sense that some people would think that it's morally right and other people would think it's morally wrong. It's an act of performing euthanasia. Participants in the other condition were given a case that was almost exactly the same, except for in this condition, it was the morally bad condition. The act that the agent was performing, which is clearly morally bad, and all participants were just regarded as morally bad. So these two conditions differ just in that way. And then participants were asked 3 questions. The key question was whether it would be right to say that the thing the person was doing was a case of doing or allowing. So the question that the researchers wanted to know is, the answer to is, does this moral difference have an impact on people's intuitions about whether it's doing or allowing? And then, in addition, there was this manipulation check. So that's just to check that this change of the supposedly morally ambiguous to morally bad actually was changed from morally ambiguous to morally bad. Participants were just asked, did the doctor behave in a way that was morally permissible? And participants were also asked, just in a more general way, is it morally wrong for doctors to remove treatment from people who wish to die? So just what do you think about euthanasia in general? So diverging slightly from what happened in the real study, let's suppose that what happened is that this first question was answered on a scale from 1 to 7, what we call a Likert scale. This second question is just yes, no, was it morally permissible or not? And then the third question about euthanasia was also on a scale. So now, let's see if people understood the big key ideas from Virginia's talk. So what is the dependent variable in this study? So someone just raise your hand. So there's an independent variable and a dependent variable. What's the independent variable?
Which vignette they receive?
Exactly. So the independent variable is which vignette did you receive? Did you receive the one about someone who does something morally ambiguous or something who does something morally bad? And what is the key dependent variable? As we always say, the DV. Go for it. What is the key DV?
Whether it's doing or allowing?
Yes, exactly. Okay. So when you get data like this, a very common way to start out is by entering them into an Excel spreadsheet. Of course, you don't have to do this. You could use like whatever you want. But a very common way of doing things like this is to begin by entering them into Excel. If you do this, the way you should do it is by having 1 row for each participant and 1 column for each variable. So obviously there are 3 variables that are going to be included, are these 3 dependent variables, the 3 things that you're measuring. And then another column is just going to be devoted to the independent variable, to which condition you're in. So some people are in the condition we labeled 0, and some people are in the condition we labeled 1. So one thing I really want to emphasize about this, which might seem counterintuitive at first, is that you should just think of condition as 1 variable just like any other. So you shouldn't think, I don't know, we have moral doing and euthanasia for the first condition, and then we're going to separately have moral doing and euthanasia for the second condition. Rather, we're going to have all of the data for all the conditions together, and condition itself is just a variable like any other. So just like we have a column for people's judgment about whether it's doing or allowing, we have a column for which condition someone was in. As you'll see on the Microsoft Word file that you were already sent that sort of goes through this example, we just arbitrarily assign certain numbers to the conditions just to indicate which condition is which. And the morally bad is going to be called 0, and the morally ambiguous is going to be called 1. So once we have the data in this form, we now want to enter it into our statistical software. So there's various different kinds of statistical packages you could use. You can use Stata, you can use R, but one that a lot of people use, and that I'm going to be illustrating today, is this particular one, SPSS. So it's not that there's any particular reason why you have to use this program as opposed to any other program, but it's a very common one that many, many people doing this kind of work use. So I thought it would be especially helpful to learn this particular one. So with that, we're going to open SPSS, which is something that you should all by now have a trial download of. And now we're going to open this particular file. So you go to File, and you go to Open, and then you go to Data. Then by doing that, you get the opportunity to open the data file that you have. It's immediately going to default to saying that it should open files of this type .sav, which are files that are this proprietary SPSS format. But we instead want to open XLS files. So you're going to be doing this yourself in a second with a different data set. But here we're going to be opening this file, the doing allowing example. It now gives us this option to read the variable names from the first row of data. So a very common way of indicating what the name of each variable is just within your spreadsheet to put the name of each variable at the very top. That's exactly what we did in this case. A very common practice. We're going to be telling SPSS that that's indeed what we did. So once we do that, SPS immediately knows what the name of each variable is. It was just able to read that from the Excel spreadsheet. So now we have these 4 variables: condition, moral, doing, and euthanasia. So right now, the condition variable and also this moral variable are coded using just this arbitrary code. As you're actually analyzing the data, that can get to be really troublesome. So it's going to be really annoying if you always have to remember which condition is condition 0 and which condition is condition 1. But luckily, SPSS allows you to enter a kind of name for each of those numbers, which will then always be reporting. So instead of having to remember it's condition 0 and condition 1, you can enter a name within SPSS. We're going to do that right now. So if you go under condition, you can change the arbitrary codes to values that have names. And we can call bad, we can call 0 the bad condition. And then we can call 1 the ambiguous condition. Then we want to do the exact same thing for this other variable, the dependent variable of being moral. So in this case, participants were asked whether the action was morally permissible, and they were just asked that as a yes/no question. So 0 in this case is no, and 1 is yes. Whoops. So when you receive your own set of data, there are also going to be certain kinds of arbitrary codes in it, and you're going to be entering the names that correspond to those arbitrary codes in the same way. Now, a really important thing to notice about these different variables that we have is that there are fundamentally different types. So there are sort of two different types that these kinds of variables fall into. One type of variable that we have are what we're going to call nominal variables. So nominal variables are variables where they're just a certain number of different groups, but those groups don't form in any way an order. So if you said philosophers and psychologists, or it could be philosophers, psychologists, classicists, and physicists. Those aren't, as it were, really numbers. We might give arbitrary numbers. We might say philosophers are 1, physicists 2, etc. But they don't in any way form an order. So these are just nominal variables, just separate groups. Then there's another kind of variable that we're going to call scale variables. So sometimes people use other names. Sometimes they're called interval ratio variables. But these are variables that form an actual scale. So for example, suppose you measure people's weights, then it's not just that you have a bunch of different weights. There's 170 and then 172, that's just an arbitrary different one. Rather, they form an order, and also that order is such that you could say that the difference between 170 and 172 is exactly equal to the difference between 172 and 174. So a really key thing that we're going to have to be doing as we're analyzing these data is differentiating between these different types of variables. So the key question we want to ask for each variable is whether it's a nominal variable or whether it's a scale variable. So consider first this variable condition. So we can just shout out, is it nominal or scale? Go for it. Now consider moral. Doing? Yeah, almost everyone would say that this is a scale variable. There are certain statistics Nazis who would say, if you think about what it really is to be like a Likert scale, where you're just judging things 1 to 7, ultimately on some really deep fundamental level that you can't consider that to be a scale variable. Almost no one doing psychology or experimental philosophy or anything would have that fascist view. Almost everyone would consider this to be a scale variable. And so we will consider it to be a scale variable. Euthanasia? Scale. Excellent. Okay, so now we understand the different kinds of variables that we've got, and we now want to ask certain questions about our data. And in asking these questions, we have to keep in mind the nature of the variable, the nature of the different variables we're looking at. So the first question we want to ask is, the first variable we want to ask is whether this sort of manipulation that we were using actually worked. So we had this condition that was supposed to be the morally bad condition, and the other condition that was supposed to be the morally ambiguous condition. And we want to know, did people in the morally bad condition more think it was morally bad, and then the people in the morally ambiguous condition thought it was? So that's just not testing the real point of the experiment, just saying, did we even come up with a manipulation that actually worked in manipulating the thing we're supposed to manipulate? So now you've got these two variables. There are two of certain kind of type. So what is it? Are we looking at the relationship between nominal and scale, or nominal and nominal? So we're trying to look at whether condition impacts this variable more. Wait, what kind of variable is this?
No.
And what kind of variable is this?
Yeah.
nominal.
It's nominal.
Yeah.
So we're looking at the relationship between a nominal variable and another nominal variable. So when you're looking at that kind of a relationship, you're trying to see whether there's an association between a nominal variable and another nominal variable. Important technique to use is this analysis that we call chi-square. So to use that, we go under analysis, and then we're going to go to descriptive statistics, crosstabs, and now we can enter two different variables, one which we're going to be looking at the relationship between. And I think it's often helpful in cases like this to, as the row, to enter the independent variable, and then on the column to enter the dependent variable. So here we're going to look at the relationship between this variable condition and this variable moral. It's in understanding what's actually going on, it's going to be helpful to print out not just the number of people in each of these cases, but also the percentage of participants within each condition who said either that it was morally impermissible or morally permissible. So if we enter that percentage, then it's going to report the percentages as opposed to just the raw numbers. And now we want to ask the specific statistical analysis. This is chi-square. So here we go. We're going to now calculate this. And what we see is the following. Within the morally bad condition, according to this imaginary data set, within the morally bad condition, 66% of people said that it was not morally permissible, and only 33% of it said that it was. By contrast, within the morally ambiguous condition, 33% said it was not permissible, and 66.7% said that it was. So now we want to ask a further question. We want to ask whether this difference that we're seeing, the difference between, say, 33% saying it's permissible in this case and 67% saying it's permissible in that case, whether that difference is significant. So if we look downward, we can find this number here, which is telling us the p-value, the degree, whether or not this thing is significant. So first of all, what is this probability? So this p-value is a probability of something, and Samin told you 10 different times what is the probability of. So the key question is, what is it the probability of?
If the null hypothesis is true, then it's a probability of getting those results under those conditions.
Amazing, yeah. So this is the probability, this number, this p-value is the probability of something, and it's the probability, had there actually been no difference in the degree to which people thought it was morally permissible in the morally bad condition and the morally ambiguous condition, that you get, just by luck, a difference that was that large or greater. So you obtained a certain difference, they weren't exactly equal, but even if there had actually, within the population you were sampling from, been no difference at all, when in your sample, there could have just been, just by luck, a certain difference. What's the probability, had there been really no difference at all, that just by luck you get a difference that's this large or greater? And the answer is only 1%. There's only 1% chance. So, is this significant? How many people say yes? It is. What did it have to fall under in order to be significant? 0.05, right. So we get a significant effect. So what this means is, there's a significant effect whereby people in the morally bad condition are thinking it's more morally bad than people in the morally ambiguous condition. So far, not a super surprising result, but one that we needed in order to see that this experiment was working correctly. So the question we want to ask now is, is it actually the case that people in the morally bad condition are saying more that the person is doing than people in the morally good condition? So now we're looking at a relationship between two variables, and is it a relationship between a nominal variable and a scale variable, or two nominal variables, or two scale variables?
Nominal and scale.
Nice. Okay, so this is the relation. We're now looking at the relationship between a nominal variable, condition, and a scale variable, doing versus allowing. And we're looking at a very particular kind of case in this. We're looking at a case in which there are exactly two groups, and for each group we have a number. We want to see whether the difference between those two numbers is significant. So the particular kind of case of a relationship between a nominal and scale variable that we're looking at is there are two groups, the morally bad and the morally ambiguous. We want, for each one, we have a certain mean, their mean level, mean degree to which they said it was doing or they said it was allowing. We want to see, is there a significant difference between those two? So the way to do that is by using this analysis that's called a t-test. So it's a t-test is an analysis that allows you to tell for two groups that you each have a mean level of, if the means are significantly different. So to do that, you go to compare means, and now you want to use an independent samples t-test if it's between subject study, and a paired samples t-test if it's a within subject study. So is this a between subject study or a within subject study? This was from Virginia's talk. Between, nice. So for that reason, we're going to use an independent samples t-test. Then the test variable, the dependent variable in this case, is going to be doing, allowing, and condition is the grouping variable. So there are two groups. This is the variable that helps us tell which groups they are. Then this other variable is the one we want to actually get the mean of, that we're trying to check whether it's different. So we have to tell it which two groups we want to compare. And in this case, the two groups are group 0 and group 1. So what the t-test now gives us is the mean for this group, the mean for that group, and the standard deviations for each. So the mean for the group that's morally bad is 4.33. The mean for the ambiguous group is 3.13. So if we just looked at the mean within our sample, it's higher for the morally bad than for the than it is for the morally ambiguous. The standard deviation tells us within our sample, is everything kind of clustered together, or is it that all the different people are saying really different things? So we want to understand now is a further question. We've got this difference within our sample. We want to know, is that difference statistically significant? So just to repeat now for the 12th time after Simeon's 10 and my 11th, what is that question? So we are going to get a p-value on this comparison. What is that p-value? Someone other than that person who already correctly answered. So it's the probability of something. What is the probability of?
Probably that you get your results are greater, given that there was no effect.
Right, so suppose that there was really no difference between the morally bad and the morally ambiguous. Just by luck, you'd expect you to get some difference. What's the probability that you get a difference this big or larger if there was really no difference? If you go down, then you can see the significance value, and it's right here. So it's a very low significance value, it's 0.006. Of course, that's not very impressive because it's imaginary data, but in the real experiment, it actually was. What this tells you is that this is highly significant. So it gets, this is a highly significant effect. We are getting a difference between the morally bad and the morally ambiguous on this variable. So now, the key question we want to ask now, this was a question I was asking in the real study as well, is suppose you look at the morally ambiguous condition. In that condition, people who think that euthanasia in general is bad are going to tend to think that this is bad. People who think that euthanasia in general is fine are going to think it's okay. In that condition, is there a tendency whereby the people who think that euthanasia is morally bad more say that it's doing, and people who think that euthanasia is morally acceptable more say that it's allowing? So within just that condition, is there a correlation between thinking that euthanasia is morally bad and saying that it's doing? So to do that, we want to select from all of our data just the participants who think that it's morally bad, just the participants who are in the morally ambiguous condition. So to do that, you go to data, then you go to select cases, and then you want to say if a particular condition is satisfied, and the condition is that the condition that has to be satisfied is if this variable condition is equal to 1. So in some sense, one intuitive way of thinking of what you're doing is that you want to exclude the participants who are in the morally bad condition. But the way you do that is not by saying take out the ones that are in the morally bad condition. It's by saying keep in only the ones that are in the morally ambiguous condition. So what we've now done is limited. We've entered a special mode where we're only going to be looking at whatever analysis we do now is only going to be done on this subset of all of our data. And now we want to look at the relationship between these two variables. So the two variables that we want to look at, the relationship between is this variable, is it a doing or is it allowing? And the variable, is euthanasia in general morally acceptable? So is that a relationship between nominal and nominal, scale and scale, or nominal and scale? Wait, say it again. Scale and scale, yeah. So it's the relationship between two different scale variables. So this is on a 1 to 7 scale, and this is also on a 1 to 7 scale. If you want to look at this kind of relationship, a helpful technique to use is to just calculate a correlation coefficient. So we want to calculate the correlation between those two variables. So to do that, we go to correlate, and then go to bivariate, and then we're just going to enter these two variables, just the doing variable and the euthanasia variable. So we're looking at the relationship between these two variables. And then this is going to give us two facts. One is this value that's called R, which Samina emphasized a lot in her talk, and the other is our familiar value, the p-value. So R, the effect size, or the correlation coefficient in this case, it tells you how strongly these two things are correlated, and in which direction. So it can range anywhere from 1 to -1. If it's positive, then that means that the more you think euthanasia is okay, the more you think that it's doing, for example. If it's negative, that means the more you think that euthanasia is okay, the less you think it's doing. Or putting it the other way, the more you think that it's doing as opposed to allowing, the less you think that euthanasia is okay. So what we see here is a very strong correlation of -0.5. So it's a correlation that's negative, meaning that the more you think euthanasia is okay, the less you think it's doing, and the more you think it's allowed. And it's a pretty strong correlation. So a really serious effect here. The next question I want to ask is whether that effect is significant. And in this case, it is significant. So I want to emphasize, as Samin also did, the difference between these two numbers. So one question you might ask is whether it's statistically significant, and the other question you might ask is whether the effect is a big effect or a small effect. So an effect can be statistically significant, even if it's a very, very small effect, if you just have a large enough number of people. So say you have 1 million people in your sample, you detect a very, very tiny correlation. That tiny correlation, though so small as to be not of no interest to anyone, could still be statistically significant. In that case, maybe we're very sure that there is a correlation, but just the correlation that we're very sure there is a tiny correlation that might be of no interest to anyone. Okay, so now I just want to do one last thing, and then we'll get. Then I'll turn things over to you, and you can begin doing your own task. So, in order to get out of this mode that we were just in, we have to go to select cases, and then say all cases. What that does is it just ends the special mode we were in, where we're looking only at the people in one condition, and puts us back into the normal mode. We're looking at all conditions. Now we want to check within each of the separate conditions. Is there a connection between people's moral judgments and their doing allowing judgments? So there'd be different ways of running this analysis, but the way that I'm going to show you now is if you go to data, and then you go to split file, then you can just split by condition. So what this means is we're going to enter a special mode. Once we're in this mode, whatever question we ask SPSS, instead of answering the question for all of the data, it's going to ask the question for the one condition, and then also separately ask it for the other condition. So it's going to give us two answers. What's the answer for the morally ambiguous condition? What's the answer for the morally bad condition? And now we can calculate the correlation between these two things within each. So suppose we calculate the correlation between doing and moral within each. What we find in this case, and this is actually in line with like a finding that comes out in a lot of this moral cognition literature, is that there's no difference. That is to say, participants who are in the morally bad condition are saying more that it's doing than participants in the morally ambiguous condition are saying that it's doing. But if you look within the morally bad condition, at whether participants actually thought it was more morally bad or less morally bad, that actually is not in any way correlated. So what we're seeing is a difference between conditions, but within each condition, no relationship between people's moral judgments and their judgments about whether it's doing that. These significant values are super high. There's no way in which these are actually coming out to be significant effects. Before we kind of conclude things, we might want to just get out of our special mode that we're in. To do that, we go to split file, and then we say analyze all cases. So what that means is, from now on, if we were going to do anything else, which we aren't going to do, it would do it on the entire data set, instead of doing it separately on one part of the data set and on the other part of the data set. So I know, yeah?
Can I add something to this last table?
Mm-hmm.
So with these two correlations, they're both very close to zero, and so you can safely say that they're not different from each other. But if one was significant, let's say in the bad condition there was like a minus 0.5 correlation, and the other one it was zero, do you want to say anything about what, I don't know, like a very, very common mistake I see is you get a significant correlation in one condition and a non-significant correlation in the other condition, and you conclude that those are significantly different from each other, and you can't do that. There's a separate test to then test if those are significantly different from each other. So just because one effect size crosses the threshold into significance and another one doesn't mean that those are significantly different from each other necessarily. You have to test that more explicitly.
Right, so that's a really helpful point. It's very related, although this is a different analysis, to the point that Virginia was making about the difference between the idea of looking at an interaction effect. So in this case, you couldn't actually calculate the statistical interaction in an obvious way, but it's not that just saying that this is significantly different from that, and saying that this is not significantly different from that, doesn't show you this further thing, that there's a significant effect whereby the difference between this and that is different than the difference between this and this. Is that I don't know if our whole discussion really helped. But the key point is, In this case, they're both not significant. If one was significant and the other was not significant, you would know that one was significant. You know that the other was not significant. But you wouldn't know that there was a significant effect whereby the magnitude of one correlation was greater than the magnitude of the other correlation. So far, I've just been going through relatively quickly a sort of demonstration of how to do this analysis. And I'm sure that as I went through it so quickly, a lot of it has already been forgotten. But you're now going to get a chance to analyze your own data, and if you run into problems, you can just ask. And so by the time you're done going through this, I think you'll really have a sense of how to actually go through these kind of things and do them yourselves. So if you look at the files that Michael sent out to you, there's an XLS file that's called deontology.xls. And this file, deontology.xls, is going to provide some data that you can now have a chance to analyze. So, hold on just a second. So these are completely imaginary data, and the completely imaginary data are about about philosophers. For each philosopher, whether the person is a deontologist or not, to what degree that person is fun, to what degree that person believes that you should donate to charity on a scale from 1 to 7, to what degree that how much that person actually does donate to charity on a 1 to 7 scale, and whether or not that person believes in God. So 0 or 1. So we're now look for this fictitious data set at the relationship among these different variables. And in particular, you're going to answer the questions that appeared in the Microsoft Word document that Michael also sent out. And the questions are as follows. So this just gives you, again, the description of what each of these variables are, so what the codes for each variables are, and what the scale that each of them is supposed to be. And you now want to answer these questions. So the question is, on the whole, are deontologists funnier or less funny than other philosophers? Second, do deontologists believe that people should donate more or less to charity than other philosophers do? Third, do deontologists actually donate more or less to charity than other philosophers do? Then fourth, within the deontologists, is there a tendency such that people who hold different beliefs about charitable donations also tend to actually make different levels of donations? And is there such a tendency among the non-deontologists? Then fifth, are the deontologists more inclined to believe in God than the non-deontologists are? And sixth, if we exclude all the participants who believe in God, are the remaining deontologists more or less funny than the remaining non-deontologists? So, obviously, this is just a kind of like preposterous thing that would actually have very little intellectual value, but I think it will help you to just illustrate certain kinds of key statistical concepts. So you've all got the data before you. You see what these questions are. Before I set you loose, are there any final questions? Yeah.
If you go back to SPSS, does it matter if you select the nominal or the scale option on the data set?
Yeah, for most analysis that you would do, it won't actually matter. You'll be in fine shape. So you won't have to change it.
You just need to know how to treat the data.
Right.
You don't need to change the...
Right, for most purposes, if you just enter into SPSS without actually changing it, then you'll be in fine shape, although you might want to. But it's not as though you'll run into trouble doing these analyses if you don't effectively change them. However, even though it's not important that you go and actually change them, it's very important that you keep in mind what type of variables each of these are, because that's going to determine which analysis you use in trying to analyze the data. Are there any other questions? Okay, fantastic. So I'll just be around. As you're trying to work toward answering these questions, just feel free to call me over. I'd be happy to help you out. And I mean, there are a bunch of other people in the room who also work on these things. You could talk to me or to Edouard. They can help you out with these questions as well. And I think that by the time you leave, maybe you'll have like this really good sense of how to go about actually doing this stuff.
You want to recommend we break into groups?
Oh yeah. So we don't have enough computers for everyone to have a computer, but maybe we do have enough computers for everyone to share them.
You want the right answer? Like, if they've asked a question.
Okay, let's start. Okay, before we conclude this session, I just want to quickly kind of go through the questions that we asked, just sort of make sure that people actually successfully got the correct answers. Just as I was going around and talking to the people, it definitely seemed like overall the answer was yes. The people were giving the correct answers to these things and were sort of understanding them. But I just want to make sure everyone's like on the same page and so forth. So let's go through sort of basic things that we had here, see if everyone sort of was able to follow it correctly. So we looked at 3 different statistical analyses. We're looking at correlations, a t-test, and a chi-square. So before I start talking about the particular questions that you guys were supposed to answer, I just want to make sure that people understand correctly, which one of them is for which kind of purpose. So you can just shout out the answers when they come for each question I ask. So suppose you have exactly 2 groups. You want to know whether there's a significant difference between the mean in one group and the mean in another group. Of those 3, which is the right analysis?
T-test.
Exactly, you're right. Now, suppose you have 2 scale variables, or what we call interval ratio variables, and you want to know, is it the case that there's a general tendency such that if people are higher on one, they're going to be higher on the other, or for example, that if they're higher on one, they're going to be lower on the other? What is the right analysis? So now, suppose you have 2 different nominal variables, and you're wondering whether these are just independent, or whether there's an association between the 2. Then what is the right analysis? Exactly. Okay, so now let's go through the sort of fictitious questions that we had to place in each of these cases and see what answers you guys actually got to them. So consider the first question. The question was, in our fictitious data set, are deontologists funnier or less funny than other philosophers? So is this a relationship between a nominal variable and a nominal on a scale, or a scale on a scale?
Nominal scale.
Yeah, and how many groups are there within the nominal variable? So what is the right analysis? And what is the answer? Okay, excellent. So now, do the deontologists believe that people should donate more or less to charity than other philosophers do? What is the right analysis?
Correlation.
Yes. Okay,
Oh, so
so those who correctly think that the answer is a t-test, why is that the right answer? So why t-test is the right answer? Why is it so? Right, so you have exactly 2 groups, and you're looking at that whether the mean in one group is higher than the mean in another group, and what is the correct answer? Right, there's no difference. So there's no significant difference in this case. Of course, in any data set, if you're sampling from the population, within your sample, you're almost certainly going to find that there's some difference between the means. But in some cases, the difference between the means is the kind of difference that's small enough, given the sample size you have, that could be due just enough. And that's exactly what we see in this case.
Can I just ask a quick question?
Yeah.
So in our group, we just talked briefly about the difference between concluding that there's no difference and concluding that we failed to determine anything.
Exactly, that's a really helpful distinction. So what we say in this case is that you have the null hypothesis, and you didn't reject the null hypothesis. It's not as though you accepted the null hypothesis. You didn't say there is no difference. All you said is that from our data set, in this data set we find no difference. So you calculated the probability, if the null hypothesis had been true, that you would have gotten the difference is big or larger. It was a really high probability. That doesn't mean that the null hypothesis is true. If you think about it if you really think about what it would mean for the null hypothesis to be true, what you end up concluding is that the null hypothesis is basically almost never true. So suppose you ask the question, overall, in New York versus LA, do people have like bigger noses in New York versus LA? So for the null hypothesis to be true, what that would mean is that the mean nose size of New York is exactly equal to the mean nose size in LA. But what's the probability of that? There's no chance that the means of the 2 populations from which you're sampling are going to be exactly equal. In almost every case, in a most literal sense, the null hypothesis won't be true. What you're doing, if you sample from the 2 groups and find no significant difference between the 2 groups, is just you're finding that in your sample, there wasn't sufficient evidence to reject the null hypothesis. And in many cases, the difference between the 2 populations will be so small that even with like absurdly high sample sets, you wouldn't be able to do it. Third, do deontologists actually donate more or less to charity than other philosophers do? What is the result? No significant difference. 4, within deontologists, is there a tendency such that people who hold different beliefs about charitable donations also tend actually to make different levels of donation? And is there such tendency among non-deontologists? So how do you calculate the answer to this question? So what is the first step?
You have to put the filter on
So there are two ways of doing it. One would be to select just the deontologist, run an analysis, then select just the non-deontologist and run the same analysis. What is the other approach? It's just a more time, that will give you the right answer. What's the more time efficient approach? You could just split the file. So you split the file, it's equivalent to that other thing that was just suggested, which will also completely get you the right answer. But you could just split the file, and then what that does is it tells SPSS, from now on, enter this mode where we're going to, everything I ask you, instead of just giving me the answer overall for the whole data set, give it for one portion of the data set and not for the other portion of the data set. So now, we either split the file or we select it. We have these two variables. Is it a scale variable and a scale, nominal and scale, or scale and, or nominal and nominal? Which do we have in this case? And what is the appropriate analysis to conduct? Wait, say it loud. Correlation. Excellent. And what is the answer?
Is it strong positive for non-Kantians and slightly negative for Kantians?
But when we say it's slightly negative, what is it? How would you actually describe that result?
I don't know.
So, of course,
Negative. Oh.
sorry,
There's a slight negative but non-significant.
It's not
There's a slight negative but non-significant correlation.
right. So there's no significant correlation for the deontologist, and for the non-deontologist there is a significant correlation, and that correlation is positive. So what does that
We
mean?
didn't do this.
What is that result? What is that result telling you? What does it mean?
We failed to establish any connection for the deontologist between their beliefs and their given.
And then for the non-deontologist?
It's a strong correlation.
And what does it mean? It's a positive correlation. What is that positive correlation?
More generous.
What?
They're more generous. They're more likely to give.
It doesn't mean that they're more likely to give than the deontologist.
Their beliefs and their actions are more closely correlated or linked together.
Exactly. Well, so as me emphasized
So
earlier,
deontologists are kind of hypocrites.
I wouldn't put it. Yeah. So what it means is that within the non-deontologist, you're finding a correlation such that the more you believe that you should give, the more you actually give. Within the non-deontologist, the two are just independent. Some people give more, some people give less. Some people believe that more should give more, some people believe they should give less. But those aren't connected to each other. Now, if you look at question 5, are deontologists more inclined to believe in God than non-deontologists are? So is this a relationship between a scale variable and a scale, a nominal and nominal, or nominal and a scale?
No.
So suppose you're looking at the association between two nominal variables. What analysis should you use?